I think we're ready. Ladies and gentlemen, good evening and welcome. My name's Rob Gell. I'm the President of the Royal Society of Victoria. It's my pleasure to welcome everyone to the Society's Young Scientist Research Prizes competition for 2022. Before we begin, we must acknowledge that all of us are located on the traditional lands of this continent's First Nations peoples. I'm coming to you, and we have people online watching this evening. Welcome to you too. I'm coming to you from Naarm, the lands and waters on which metropolitan Melbourne's been settled, and the country of the Wurundjeri and Boonwurrung peoples of the Kulin Nation. And I invite those joining us via the YouTube live stream to acknowledge the traditional custodians of your own country and join me in paying respects to elders past and present, and likewise extend that respect to any First Nations people who have joined us in our meeting tonight. I'd particularly like to welcome the many family, friends and PhD supervisors who've joined us with our members to support the finalists for this year's competition. This is one of the highlights of the Royal Society of Victoria's calendar each year, and certainly something we look forward to with great anticipation. We have a terrific night ahead of us. Hearing from PhD graduates means that we all get to learn about the latest emerging science from the latest emerging scientists. And as our eight finalists were selected from a highly competitive field of 63 applicants, we have some truly significant work, some high quality work to share with everyone this evening. Anyone who works or indeed tries to work in research can tell you it's just intensely competitive and demanding, the profession that these people work in. And particularly in the research sector, as public funding continues to contract. Not only are there much fewer funded positions in our research institutions than there are graduating PhD students, there's also a much greater demand upon all scientists to not only conduct research and present and publish results, but also to demonstrate their skill as a science communicator to non-scientific audiences, which includes governments and industries that are increasingly the most viable graduate destinations for our highly skilled postdoctoral workers. This means mastering the esoteric language and skill base of your discipline, and also developing the ability to make this refined knowledge both accessible and engaging to others through clear, engaging communication that both educates and persuades those who are unfamiliar with your discipline. So, whilst our finalists here tonight, due to the quality of their scientific work, they're also going to be assessed by our judges on the clarity of their presentations for scientists and non-scientists alike, including their ability to respond to questions from our judges, and if time allows, some from our audience. We have 8 presentations to attend to tonight, so you'll need to stay focused. They'll come through pretty quickly. They'll all pack a punch, and you'll need to concentrate on each one. This year, we've selected the order of the presentation by category in reverse alphabetical order, followed by a family name in alphabetical order, just to confuse everybody. Each presentation will be limited to 10 minutes, after which we'll have about 5 minutes for a question and answer session with our panel of judges for each finalist. And we should offer a warm thanks to our counsellors of the Royal Society of Victoria who are here tonight, and they will be our judges. I think we can begin, Mike, with our first one. Just so you know, we'll have the 8 presentations. Then we'll ask you all to go downstairs to enjoy some refreshments. The judges will retire to the Cudmore Library to do their thing, and we'll join you downstairs with the announcements of prize winners at the end. So enjoy your time downstairs and hope you win. So let's begin, Mike. The first presentation is from Mashid Sadikpour from RMIT University. Her lead supervisor is Associate Professor Stephen Davis, and the presentation is Developing a Privacy-Preserving Retinal Biometric Recognition System.
Just a quick word to all of our contestants tonight. At 8 minutes, you're going to get a little, and that'll give you 2 minutes to finish up, okay?
Hello everyone, my name is Mahshid. My presentation is about developing a privacy-preserving retinal recognition system.
Right over to the microphone so they can all hear you properly.
Biometrics are those physiological characteristics of individuals which are unique to them. And because of that, we can use them to authenticate people. Examples of biometric characteristics include a fingerprint image or, for example, a retinal image. From these biometric characteristics, we can extract biometric features. For example, from the fingerprint image, we can extract minutiae. Or from the vessel pattern in the retinal image, we can extract a vessel skeleton. These biometric characteristics and biometric features are usually represented in a mathematical format. For example, the minutiae can be represented as a set of X and Y coordinates with their relative orientations. Or the vessel skeleton can be represented as a spatial graph. Generally speaking, biometrics are very convenient for the purpose of human recognition because unlike passwords and tokens, we don't have to memorize them or carry them around with ourselves. And because biometrics are who we are, not what we know or what we have, they're easy to be used. However, there are privacy concerns related to the use of biometrics. Because biometrics are noisy and fuzzy in nature, we cannot use conventional encryption functions to protect them. And it has been shown that unprotected biometric templates can be reverse engineered to biometric samples. And that is a huge privacy concern. Because firstly, biometric samples contain sensitive personal information about us, information about our gender, age, ethnicity, and even about our health condition. About our health condition, for example, we don't like the fact that the health insurance companies can gain information about our health condition if they can access our biometric samples. Also, each individual has a limited number of biometric samples. For example, each one of us has maximum 10 fingers to take prints of. And in case these biometric instances are compromised and shared publicly, they will be lost forever. Because, for example, if your credit card is lost, you can cancel it. If your password is compromised, you can change it. But if your fingerprint is shared publicly, would you be able to cancel your fingers? Can you order a new set of fingers for yourself? In addition to that, if they are compromised, spoofs can be created from them. With today's technologies, it won't be a very difficult task for a criminal to generate, for example, a gummy fingerprint of your fingerprint samples. What if someone commits a crime wearing your biometric characteristics? Because of the mentioned privacy concerns, we should be very careful about the biometric templates that we store inside the databases. They should have fundamental properties. The first property is irreversibility of the templates. Imagine a face recognition system. A user is enrolled in the system and a template will be extracted from his face image. Irreversibility requires that it should be mathematically hard or impossible to reverse engineer this template to the face image. The second property is cancelability of the template. Again, consider a face recognition system. The user is enrolled and a template is stored. In case this template is compromised, we should be able to cancel this template and re-enroll the user using a new template. The last property is unlinkability of templates. Unlinkability makes sure that if a user uses the same biometric characteristic to be enrolled in multiple applications, we cannot link the templates of the user among different applications to each other. This is not very difficult to imagine because we have limited number of biometric samples. So if a user is enrolled in two different applications using his face image, it should be mathematically hard to link or relate his templates. but conventional biometric systems extract features and store them inside the databases as unprotected biometric templates. And this is a risk because in case the security of the database is compromised, an attacker can reconstruct the original biometric sample from the unprotected biometric template. The underlying idea of the work that I conducted during my PhD was to avoid storing the unprotected template inside the database and instead storing it in a protected way that is irreversible, unlinkable, and cancelable. Imagine I want to be enrolled in such a system. My retina will be presented and a graph will be extracted from it, but we don't want to store this graph inside the database. Instead, we compare it with a cohort of other graphs that are completely different and independent from my graph. And we will calculate the distances between each of these cohort members and my graph. And we will store these distances inside the database as my data. I have shown that it is mathematically hard and computationally impossible to reverse engineer these distances to the biometric sample. We have published results that showed that the state-of-the-art methods that can reconstruct face images from these distances cannot work on retinal images. Hence, what we store inside the database is irreversible. I also evaluated the accuracy of the system that uses these protected templates. The accuracy was approximately 99%, which is very encouraging for a system that protects the privacy of users. I also checked the cancelability of templates. Our templates can be cancelable. We can use a new cohort and re-enroll the user if the templates are compromised. Lastly, we evaluated the unlinkability of our templates. I evaluated the linkability scores of our templates, and the linkability scores are represented in the last row of the table. We achieved very low linkability scores compared to other existing biometric systems in the literature. This shows very highly unlinkable templates. In conclusion, the work that I conducted during my PhD proved that the general consensus among the researchers in biometrics community that any type of biometric modality can be recreated from distance scores is not correct. And in fact, retina cannot be reconstructed from distance scores. The system that I developed is the first and only privacy-preserving retinal recognition system. During my work, I generated a synthetic retinal dataset, which is the largest dataset of high-quality retinal images. And the software for the developed system is publicly available for the research community. Here are the references that I used during my presentation, and I thank you for your attention.
Now, before we go to our judges for questions, any particular reason why you use Justin Trudeau?
Yes, I'm a fan of.
You're a fan of that,
politician.
I'm very interested in that. I've been watching just recently on BBC First, I think, a program called Capture, where they're pinching video, and it's scary. So I think it's in your space. Let's begin. A question from one of our judges. Rob Day.
Rob.
I was very impressed by this, and I imagine that your work's going to end up being used extensively. But when somebody wants to check whether you are the person who is on the database, they will need to take and process a retinal scan. And one of the questions that then arises is just how repeatable are the distance scores if you have a change in the total database of other people that you're comparing your retinal score with. So would you find that later on when somebody is checking your retinal score, whether would they end up with the same set of distance scores?
That's a good question. We check that even for identical twins, which have very similar biometric samples, the distinction is good enough to separate even identical twins from each other. So the distances would be enough to distinguish between people. That wouldn't be a serious problem. Did that answer your question?
Not quite. What's important is the other people who are, or the other retinal cohorts that you compare your retinal map to, and if that cohort changes, then how much does that change the distance scores?
I don't understand the reason to change the cohort until the templates are compromised. But if we have a good reason to change it, because the underlying machine learning algorithm that is used is trained for each individual separately, it wouldn't impact other individuals. It can be trained in 2 minutes. So it wouldn't be a difficult problem.
Let's move on to David Walker.
Yeah, that was great talk. Am I right, though, in thinking that your fingerprint doesn't change with age, but the distribution of blood vessels in your retina might, so that from time to time it won't be personal, it won't be individually personal?
That's a good question, but I'm afraid it's the opposite way because fingerprint can change during time because people use their fingers and it can be impacted even by disasters or skin conditions. But retina can only change if people develop diseases like the diabetic diseases, which is compared to fingerprints. What can happen to fingerprints is very rare.
Thank you, Astra.
Well done on a fascinating presentation, and at the moment very timely. We're all interested in security of our personal information. I'm intrigued by how you came to the thought of using the cohort data to map the template against as your step in protecting the data. What was the inspiration for that?
It was actually the idea for that, and the credit for that goes to my supervisors. The initial idea was for my supervisors, and we tested it and it worked in terms of accuracy, and then we decided to check the security and privacy aspects. So I think because they have worked with network sciences and graph theory for a very long time, that idea came to their mind. And when they talked about it to me, I also thought it's a brilliant idea.
We have an audience question, Mike. How much time do we have?
We've got one quick question. Here we go.
Thank you. A very intriguing topic and a wonderful concept. My question relates to the actual software, the code that you've generated. I can see its applicability. What I was wondering is how big is the actual file that is being transmitted and then returned? And the reason for my question is twofold. One is whether that data can be stored over a distributed network, which further increases privacy. And the second, of course, relates to speed of user experience, which will impact adoption.
Yes, the size of the cohorts at this time is 233. So the files are very small and they can be used in distributed systems as well. And for your second question, it will take multi-seconds to recognize individuals. So it won't even take seconds. So the system is efficient and very fast.
Very good. Thank you.
Thank
That was
you.
excellent. Round of applause, I think it's reasonable. And whilst Mike gets organised with our second presentation, it'll be done by Mr. Yongcheng Wang, who's from the University of Melbourne. His lead supervisor is Dr. Gang Li. And the title, Mike will put up in just a second.
A moment. That's right at the end of the presentation because we just tested it. Here we go.
As you can see, is solar-driven CO2 capture and production from the air. Welcome. Where's Dr.
Here he comes.
Come here.
And hello, everyone. I'm Yongqiang Wang from the University of Melbourne, and today's topic is solar-driven concurrent CO2 and water production from the air. And the story starts from the climate change. And we all know that we are facing climate change and global warming in this century. And as we can see in the right line here, the right line shows shows our emission target in this century. And as we can see, we need to achieve net zero greenhouse gas emissions in this century. And for achieving this target, we need to develop some carbon removal technologies which can directly remove carbon dioxide from the air. And by middle century, we should have the ability to remove 10 gigatons CO2 directly from the air per year. And the question is how to achieve that. And now I have a concept, the air to X concept. And in this concept means directly converting atmospheric CO2 to some chemicals such as methane and methanol. And in this concept, we conduct direct air capture first. Direct air capture means directly capture CO2 from the air and get CO2 products. And then we can use the CO2 product to generate some our target products such as methane and methanol. And of course, for CO2 conversion, we need hydrogen. And for hydrogen production, a water electrolysis powered by renewable energy is a promising method. So now we need water. So the problem here is, can we get CO2 and water concurrently from the air? And according to my research, the answer is yes. And firstly, we need to develop a material with high affinity to CO2 and water, especially low concentration CO2 and water. So I prepared a material functionalized with amine groups. And the amine groups can react with CO2 and low concentrations and low temperatures. And the material also has some hydroxyl groups for water absorption. And when this material contacts with air, the atmospheric CO2 and water would be absorbed or trapped in the material. And if we apply heat to the material or increase the temperature, the CO2 and water would be released. So then I designed a process, a temperature swing process for this material. And this process includes 3 steps: adsorption step, desorption step, and cooling step. And in the adsorption step, it means we use a column packed with my material, captured CO2 and water from the air. And in the desorption step, I heat the column and increase the temperature and collect the CO2 and water product. And the 2 products can be easily separated through a condenser. And in the cooling process, we just use the fresh air to remove the heat and reduce the temperature. So obviously, we need thermal energy to operate this process. So I was thinking, can we use renewable energy to provide the thermal energy required by this process? We know that photothermal conversion can be used to convert solar energy to thermal energy. For example, solar hot water systems has been commercialized for a few decades. And based on that, I designed this solar heating column. And this column includes this steel tube, which is a black tube here, and the vacuum glass tube. And this black tube is coated with solar absorption metals for converting solar energy to thermal energy and for heating the whole system. And the vacuum glass tube here is to reduce the heat loss because it's vacuum. And I tested the energy conversion efficiency of this tube, and it's around 63%. It means 63% of the renewable energy can be harnessed and converted to thermal energy in our solar heating column. And now, based on the material, based on the process and the solar heating tube, I established this prototype for harvesting CO2 and water directly from the air. And we can just look at the bottom picture. The bottom picture shows the experimental facilities used in the desorption process. And it includes a solar heating column packed with my material for CO2 and water capture, and a thermocouple for temperature analysis, and computer data aggregation system, and a condenser for separating CO2 and water. And finally, a syringe for gas collection, especially the CO2 gas collection and recording the volume of the CO2 product. Okay, let's move on to my experimental results. And let's start with the CO2 capture performance. And this slide shows CO2 loading of the material and the material temperature and the solar flux in adsorption and desorption steps. And the CO2 loading here means the volume of CO2 that we can trap in the material. And in the adsorption step, the CO2 loading increases because the material is always capturing CO2 from the air. And we can see that the maximum CO2 loading is around 23 milliliter per gram. It means the material has the ability to extract 23 milliliters per gram. And in the desorption step, with the irradiation of solar energy or sunlight, the temperature increases. And when the temperature reaches 90 degrees C, we can see the CO2 loading starts decreasing. And the CO2 product can be fully released or collected in just 1 hour based on the solar heating. And now we have CO2. We have this CO2 product. So if we want to use this CO2 product for further CO2 conversion, we need to focus also on the purity of the CO2 product. So I also analyze the CO2 purity. So as we can see, for the product, for the first 200 milliliter product, no CO2 can be detected because it's just the air in the column. And for the product collected after 500 milliliter, a very high CO2 purity could be obtained. So it means this prototype has the ability to produce high purity CO2 from the air. And I also compared the distilled water and the water produced from the air. As we can see, the water product looks clean. And for the productivity of this prototype, if we assume that all the produced water can be electrolyzed to hydrogen, so we can calculate the hydrogen productivity based on the water productivity. So here, I just present the CO2 productivity and the hydrogen productivity. And the results shows that we can get 3.5 liters CO2 and 7 liters hydrogen from for just one cycle using this prototype. And the volume ratio of hydrogen to CO2 is around 2. And this ratio is good for the production of methane and methanol because the reaction product, water, can be electrolyzed again to hydrogen. Finally, I would like to briefly summarize my research works. In my research works, a solar thermal device was developed to harvest atmospheric CO2 and water directly, and this device was able to produce 3.5 liters CO2 and 6 grams water per cycle from the air. And in the near future, I would like to integrate water electrolysis with my prototype to directly produce hydrogen from the air. And I hope that my research would be helpful for establishing an artificial carbon cycle. Thanks for your listening, and this is my presentation.
Just let me say a couple of words. I'm delighted to hear that I actually have a business client, an emissions intensive industry, and they've just put out a net zero program by 2050, but they're saying that 88% of their emissions reduction has come from technologies that haven't been developed yet. They must mean you. So I'm really pleased to see your presentation.
Okay.
Yeah. Question from Sid Verma.
Thank you, Michael. Thank you. Thank you for your presentation. Excuse me. What I liked about the way you explained fairly complex topics to a very non-sciencey person like me. I come from a business world. I was able to understand it very clearly. So thanks for doing that. My question is, how do you scale this? Who's going to buy it? I mean, to me, I come from a point of view that no amount of science and research is of any use unless we can genuinely apply that to the broader audience. Who will be your first customer?
Actually, it's a very good question. And I told 3 technologies here: the direct air capture, the water electrolysis for hydrogen production, and CO2 conversion. Unfortunately, all the 3 technologies cannot be commercialized now because it's just in its early stage. And I told in my presentation, the net zero emission target should be achieved in this century. So we have many decades for us to achieve this purpose. And with the development of the 3 technologies, such as direct air capture, water electrolysis, and especially for the development of cheap renewable energy, renewable electricities with a cheap solar panel, we can get, only with that, we can get cheap hydrogen and cheap energy. So it's a long journey, actually. Currently, it's not possible to scale up. Yeah.
Peter, I think we can take one from Peter. Yes.
Just a quick question from what you've been saying. Do you think it's possible that by the end of this century, it's be able to have a procedure which will be reducing CO2 back to in the atmosphere towards zero, or not zero, but at least somewhere near it was like 50 years ago, for example?
Yes, actually, I think in the middle of this century, we will have the ability to achieve this purpose, to directly reduce carbon dioxide concentration in the air. Yeah, I think this is possible.
Jane?
I have 2 questions for you. Thank you for an interesting and stimulating presentation. The first one is, you extract carbon dioxide from the air and then store it. So I'm not clear what's then meant to retain that carbon dioxide or how that's to be used. And the second part of the question is, you also generate methane, which is another greenhouse gas 7 times more potent than carbon dioxide in the air. What is the intent for the methane that you generate?
Okay. currently, there are some direct air capture projects just store the captured CO2, but the carbon dioxide storage is a choice, but CO2 conversion is another choice. Yeah, we can do it simultaneously. And for the methane production, and we all know that methane is a fuel, right? And it's also a feedstock for our chemical industry. So we can just use methane as a fuel, or just use it as the feedstock. So we don't have to worry about the greenhouse effects of methane, I guess. Yeah.
Yeah, so use it for industrial heat, things like that. Is there another question?
Actually, there's one from YouTube.
Oh, yeah, one online? Okay.
Okay.
Thanks, Scott.
All right. The question from YouTube is, how much water is needed to capture all of the airborne CO2 released by 2050?
Sorry?
So how much water is needed to capture all of the airborne CO2 released by 2050? What scale is that?
How many litres specifically?
Yeah, it's a good question, but so that's why we are doing research here. Yeah, it's a good question actually. Yeah.
I think that's it. That's our time. There's one right at the back. An audience question.
So this is a really interesting concept. Love the idea. It has huge environmental impact, which is why you're going towards it, which is brilliant. If we think about companies that are using CO2 right now, and consumers are directly interacting with it. So I'm thinking about like PepsiCo, who produce carbonated beverages, or even wineries or breweries. Is there a way that we can enter that market to start branding products that have green CO2 within it to create a bit more consumer advocacy for this particular product?
Yes, it's a very good concept, and the answer is yes, because we all know that the air is clean, and the CO2 also we can get really high purity CO2 from the air. So so I guess we can also get the food grade CO2 from the air. So I think it's possible, but the only problem we have to pay attention to is the price of CO2 captured from the air. If we can reduce the price to around, $100 per ton CO2 captured, so I think this business would be very, very good. Yeah.
Very good. Well done. Two excellent presentations in the physical sciences group. We now move on to two presentations in earth sciences. And the first is from Paul Chung from University of Melbourne. His lead supervisor is Associate Professor Stephen Livesley from Melbourne Uni. And the presentation, there we are, measuring the microclimatic impacts of turf irrigation in a temperate summer season.
Simply speaking, that is how much we can cool backyards with water.
Very good.
Speaking of water, here we go.
Thanks. That would be very helpful. My name is Paul. I would like to begin by acknowledging the traditional owners of the land on which we meet today. I also would like to pay my respects to the elders past and present.
Right across to the microphone so everyone can hear you.
Okay. Yeah. Backyards are an important space for people to socialize, exercise, and relax because they are easily accessible. And backyards are also good for children to exercise and expose themselves to nature because they are truly private and secure. However, our climate is getting warmer. It is expected that the number of very hot days in Melbourne will triple by the end of this century. And that's a challenge for people who want to stay outdoors because when air temperature increases, it is less comfortable for people to stay outdoors and their willingness to stay outdoors will decrease.
Planting trees is regarded as a silver bullet to cool the environment in urban areas. But planting trees in this kind of backyards is not feasible because they are too small. We need to figure out another solution for that. Perhaps we can remove the lawn in the backyards and converting them to swimming pools. We can have a poolside party for adults and swimming lessons for children. That sounds really cool, literally and emotionally. But my colleagues will disagree because we want more green space in our neighborhood. But actually, water is the key to cool these backyards because water can change our climate. And therefore, I'm proposing to use water to change, to make our backyards cooler. And this is how it works. When radiation hits the ground, it can be converted to either sensible heat, latent heat, or soil heat. Sensible heat is the heat that we can feel. It can change air temperature. Latent heat is associated with evaporation and transpiration. It can change humidity directly and air temperature indirectly. I'll explain that in a moment. Soil heat is the heat stored in the soil. Since energy is always conserved, radiation is equivalent to the sum of sensible heat, latent heat, and soil heat. And the relative size of these heats depends on soil moisture content because it controls how much evaporation and therefore control latent heat. If we can increase latent heat, sensible heat has to reduce and air temperature has to reduce too. Let's look at a simple example. On the left, when soil moisture content is low, sensible heat, the red line, and latent heat, the blue line, are similar. On the right, when soil moisture content is high, the latent heat became larger because there's enough soil moisture for evaporation and transpiration. And the overall impact is that sensible heat became smaller and we have a lower air temperature. In my PhD research, I proposed using irrigation to cool backyards. And this is different from traditional irrigation. In traditional irrigation, people want to irrigate by night because they want to improve water use efficiency. In contrast, I propose irrigate by day repeatedly to maximize evaporation and transpiration because in that way I can get more cooling benefits. It is feasible to irrigate by day because we can use grey water instead of potable water to irrigate our backyards. To understand the cooling benefit of irrigation, I set up this experiment at Burnie campus of the University of Melbourne. My hypothesis is that irrigated turf is significantly cooler than non-irrigated turf in the afternoon. These backyards, simulated backyards are similar to the ones that you saw in the satellite image. And the unique thing about this experiment is that it is a controlled experiment, which is not very common. And it is an urban study, which is not very common either. Lastly, we have 3 replicates for each treatment. At the center of each plot, I set up a weather station to measure the impacts of irrigation on soil moisture, soil temperature, air temperature, and a number of other things. I measure air temperature at 1.1 meter above ground because this is what we experience. This is the data from the summer of this year. The red line is the air temperature changes of the non-irrigated turf. The blue line is the air temperature changes of the irrigated turf. And the irrigated turf received 1 millimeter of irrigation for 4 times every day. I calculated the cooling benefits by subtracting the blue line from the red line, and this is what I got. Before the start of the irrigation at 12 o'clock, there was already some cooling benefits at minus 0.5 degrees Celsius. And what's even more important is that after each irrigation event, the cooling benefits became stronger significantly. From 12 p.m. to 4 p.m., the average cooling benefit was minus 0.9 degrees Celsius. To put this minus 0.9 degrees Celsius in context, we have to look at other the impacts of other cooling strategies like tree shade. In Melbourne, tree shade can reduce air temperature by 0.7 to 1.5 degrees Celsius. So in comparison, irrigation, the performance of irrigation is actually pretty good. Apart from working on the experiment at Burnie, I'm also working with Southeast Water to measure the cooling benefits of irrigation in other people's backyard. We are working on it in a housing development called Gravo, which is located in Lyndhurst. Each of the house in this housing development is equipped with rainwater collection system, recycled wastewater system. They can use these alternative water sources to irrigate their backyards and gardens. I've also developed a smart irrigation algorithm to optimize irrigation amount based on the potential evaporation on the previous day and the current soil moisture. If the previous day is a bit dry, the algorithm will automatically irrigate a little bit more today. We are also developing low-cost weather station to measure the air temperature in all 460 private gardens in the community, because we want to know the impacts of irrigation on a larger scale, not just the backyard, but the whole community. To answer more complex questions, like how do we use irrigation to cool Australia's towns and cities, I need to use computer models. And currently I'm validating and calibrating some urban climate models like this one, UTNC, with the experimental data that I've collected. And after validating the model, I can use it to predict the cooling benefits of irrigating with different amounts of water on different soil and vegetation types, and in cities with different climates. Hopefully, my research and collaboration with the industry, the public, and computer modelers will help Australia to better cope with the warming climate and allow people to spend more time in their backyard to exercise or to have a poolside party if they like. And lastly, I want to thank my supervisors over there, Stephen Livsley, Kerry Nice, and also the technical staff at Burnie campus who support my experiment, and also my research partner, Southeast Water. Thank you.
Now, Paul, I happen to know that Melbourne Water Corporation currently dumps 120 gigalitres of Class A water into Bass Strait every year. Is that correct?
Yeah, they should give me the water because
I think so.
Yeah,
I think so. We could cool the eastern suburbs by a degree, correct?
Absolutely, yeah. The campus manager complained about me using too much water.
Well, so let's start with some questions. That was really interesting. I think urban heat island effect is going to be something we're going to suffer from in coming decades. So that's very interesting. David?
Can I ask you, how far above the ground did you measure the air temperature? And would any effect of the cooling effect of the water be completely lost if there was any wind?
Yeah, that's a good question. We measure the air temperature from 1.1 meter above ground, which is the height that we human experience. And that's true. It's true that if there is wind, the cooling benefits will be lost. And my data also show that on windier days, the cooling benefit is smaller. But if that's why we are looking at irrigation at a larger scale, in the community scale. What if all the backyards and gardens in the community are irrigated, and we can, even though the cool air is blowing downwind, we are still benefiting our neighbor next door, if you like them.
Yeah. Very good. Another question? Robert Dave?
So most backyards in these new housing developments are very small, but some people, of course, will have larger backyards and be able to introduce trees and so on as well. Is the effect of the irrigation on the grass likely to add to the effect of the tree, or would there be some loss of effectiveness in a tree shade?
Yeah, that's a perfect question because in the second year of my PhD, I did another experiment. I added trees to the plots and measured the synergistic impact of having trees and irrigation. And I haven't looked at the results yet, but what I can tell you is that the trees with irrigation perform much better and they have larger canopy area. And I'm pretty sure that irrigation will help plants to establish, and the cooling effect with trees and irrigation will be larger than having just tree and irrigation separately.
How are we going for time, Mike? Jane?
Fascinating topic, because from an emergency management point of view, the 7 most lethal natural disasters Australia has experienced are all heatwave events, with the highest mortality of all natural disasters. So this is an important thing in terms of managing heat exposure for human beings. I'm interested to know, in terms of the volumes of water required to irrigate on a per square metre basis, whether or not the homes will generate enough grey water to allow a maximum backyard size. So have you started to consider how much water? And you chose a 1 millimetre event. Is it appropriate to have a 2 millimetre event if that much water is available? Would that have additive cooling capability?
Yeah, great questions. In AgriEvo, they have provided a very good demonstration because they have managed to collect enough rainwater and recycled sewage water to irrigate their backyards. And at one point, we asked them how much you can irrigate. And they told us that you can irrigate unlimitedly because their system are collecting enough water to irrigate as much as you want. And the other question is about whether the cooling benefit will increase with the amount of water you irrigate. Our experiments show that if you're just increasing from 0 to 1 on a daily basis, if you irrigate if you below 4 millimeter, you can get an increase in cooling benefit. But after 4 millimeter, you are saturating the soil and you don't get any more cooling benefits. Yep. So yeah.
That's probably all the time we
have. If you have too much water, make a swimming pool.
Okay. Thank you, Paul. That was terrific. Well done. I'm thinking this is a perfect example where we need to have good science informing urban planning. And I don't know whether you talk to too many urban planners, but perhaps that's something we can do. Now, this presentation is one that I know that we have a former president of the Royal Society in the audience, and he'll be interested in this. This is a rocks. This is rocks, Billy. Hao-Xiong Lim, welcome, from Monash University. His lead supervisor is Associate Professor Oliver Nebel, and his presentation is Timescales of Granite Infancy, Advances in Granite Geochronology.
Thank you very much. Thank you and welcome for my talk, and thank you very much for inviting me. This great chance for sharing my research with these nice people. Okay, let's start. So my research topic is about dating rocks. So I'm dating granites because I'm studying granites. So it's all about the story when the granite comes of age. So first of all, I want to give my thanks to my co-authors and Monash University, where I got my PhD, and IGRU Economic Geology Center in James Cook University, where I'm working. Here's the contents. Do you know the oldest mineral in the world. It's a 4.4 billion years of zircon found in Western Australia. So the mineral is zircon. By the way, I will call, oh, sorry. I will call million year into M year or MA. So the size of this mineral is 50 micrometers. How amazing that this small size of the grain includes almost the entire history of the Earth. So this is stated by uranium-lead isotopic age dating. So what is isotope, by the way? So isotope is just one of the elements item we can find in the periodic table. So for example, for this carbon 12, 13, it's a different isotopes. If you see the core of the atom, you can see protons and neutrons, and 12 means 6 protons and 6 neutrons. And carbon 13, the only difference is it has 1 more neutron. So I will just go with a fatty friend. For the uranium isotope, it's the same, except the uranium isotope is really unstable and decays by itself. So we call it a radioactive decay. And we call parent isotope for the previous one and the daughter isotope for the byproduct. So this is the example what happens in the mineral. So when the mineral crystallized, the age is of course 0, and parent isotope percentage is 100. But as time goes by, it produces daughter isotopes. So the percentage of daughter isotope is increasing. So what I do is I collect parent isotopes and daughter isotopes and get the ratio and get the age information, because it happens with a certain time scale. So it sounds really exciting. We get the oldest age from the zircon. Why don't we do more? That's what exactly scientists did. For the couple of decades, they used zircon, and zircon is now the dominant method for dating. It's almost more than 90% of the all age dating study. We can actually use different minerals if the mineral has a uranium, but zircon is the number one. And for the granite, I said I'm studying granite. It's more serious. So granite is granite is the magma-derived rock. It chills deep underground and chills and make the granite. It forms a platform you step on. And the study area is Mount Buller. We know Mount Buller, and I visited here in the summertime. So I collected granite and get the zircon. Granite naturally have many zircons, so it's obviously that zircon is predominant. I mean, by far the most popular way for dating granites. But I want to say something different side of this technique. Is it that perfect? Is it that perfect to avoid any other age dating methods and take the more than 90% of dominance? I would say no, because it also have many problems. The biggest problem for this one is age spreading. If you see this age plot, you can see the ages in the tick marks. And for this example, the age is spreading from 900 to 780 million years. And for this example also, the age is in the x-axis and age spans over tens of millions of years. So think about your kid is 20 plus minus 20 years old. It's nonsense. The aim of the goal is this, to address the current limitations of zircon age dating, and somehow I did. And for the solution, I can say there's 2 solutions. First one is we improve the current technique. And the second one is finding another way for dating. So what I'm gonna do is I use apatite and titanite. It's a different minerals for kind of extra minerals for testing the possibility. So the method I'm going to use is I use a certain method to the zircon to improve the technique, and use the same technique to the apatite and titanite, different minerals. So what technique do I use? I use 2-in-1 laser analysis. Just one laser analysis for getting isotope composition is pretty normal. We just jab the laser on the surface of the surface of the grain, and get the isotopic composition. But this one is different. We get the trace element additionally. So how does it work? It works like lie detector test. Do you know how it works? It gives you an electric shock if you tell a lie. The one of the hypotheses that we get the erroneous age for the grain is crystal contamination or corruption, I say. So if the surface is crystal clean, the age out of it, based on the isotopic composition, will be reliable in trace elements as well. But if the surface is stained and the age out of it, you will get a good amount of electric shock. This is the result from zircon. For the zircon improvement, we get the trace element is the list of the trace element and concentration and different patterns of compositions. And I separate these compositions, and these two one I filtered out because this is the result of contamination. And after this filtering process, the data is significantly improved compared to the previous one was spreading a lot. Now it's much focused. And the same thing applied in the apatite and titanite. And this is the result. Compilation of different ages from zircon, titanite, apatite, and the previously known age for the study area. Before the filtering, the ages overlapping each other, so we cannot actually see much difference. But after the filtering, we get a more constrained age range. And now we can see interesting relationship. Zircon, titanite has a similar age range, and apatite is somewhat younger. And the previous study that defined the age of the Mount Buller is obviously younger than what I've done in this study. So the conclusion, we found that titanite is a good alternative for zircon, apatite less so. And now I know that trace element monitoring, filtering works really well, improves dating quality a lot. So for the significance, if you remember the younger age about the previous study of the granite, it actually same for every different granite in the Victorian area because it used the older technique. So if they use the technique I suggested in this study, it will get a different age. So I would say it's time to understand the real history of the platform we step on. And the second thing is I want to say another fact in this technique. There's actually a couple of ways for the age dating, but it follows a trade-off relationship, like faster, cheaper one is less accurate, and the slow, expensive one have a more accuracy. But with this technique, with this trace element filtering and monitoring, I would say this technique is now faster, cheaper, and even accurate. Thank you for listening. Any question, comments, welcome.
I've done a bit of thinking about this. So tell me, how long do we think it takes a granite pluton to cool?
It takes, geophysics say that it takes only 1 million years. So,
right.
Yeah.
Thank you for a really interesting presentation. 2 questions. Why does this matter? And not just about a cheaper, quicker, faster, more accurate test, but why do we need to have that accuracy? That's the first part of the question. Second part is, how does identifying the trace elements modify the aging of the granite that you've selected?
Thank you. But can I ask for the second question? I couldn't understand.
The second question is, you get a more accurate idea if you've identified the trace elements, okay, in terms of the age of the selected granite. Why?
Okay, I will answer the first one first. For the accuracy, yeah, everything is actually trade-off. So it's very fair to ask that kind of question. Normally, this technique is is famous for cheaper one and faster one. And many labs in the world, they often have a kind of budget problems, and it is sometimes their only option for age dating. And if they get additional kind of possibility to get a higher accuracy, it will be really, really helpful for them. So I would say this is helpful for them. And for the trace element filtering, why I did it? Because I was really annoyed by zircon research result in the many different granite study, but age was really, really spreading with this technique. And I just want to have something better age. And the trace element actually doesn't make a difference, but I just filtered out the bad data. So it's important to get a more number of data to have a more number of survivor data.
Curator of rocks at the museum.
I'm not that familiar with zircon dating, actually. A very interesting talk. As you know, Victoria is full of granites. There are, last count, there are over 400 different granite intrusions, big ones, small ones. I don't think there's any coming at the moment. But where you have one granite intruding another or interfering with another one, is there any resetting of these ages under your method?
Oh, that's a sharp question. Yeah, it depends on the different minerals. So about the previous data result in the biotite and hornblende, do you remember the younger ages? It actually affected by kind of afterwards event, like if there's a hydrothermal fluid, hot fluid, or hot magma, the age is resetted. So it could be one of the reasons that it has a younger age, because it's a reset age. But you don't want reset age. We want a real age.
The elixir of life. Yeah. How are we going for time, Mark? One more.
Time for one more. If anyone got a question?
I'm sort of wondering whether our other presenters have got questions as well.
Oh, that's dangerous.
That's dangerous, isn't it?
Not by Paul.
So I really enjoyed this. I thought this is really interesting work because knowing exactly when things happen is a fantastically important in understanding how subsequent things change. And but my problem is that I don't understand why the crystallization point is a 0 point. So is it possible that the uranium is actually fixed in place before crystallization? Why do you think the cooling is important in fixing that 0 point?
That's a good question. You have to study PhD for this. Yeah, you're right. Uranium is actually everywhere. But the reason why we say it's kind of starting point with the 0 age of the mineral, because mineral is crystallized, so it's literally 0 age. But actually, daughter, do you remember the parent elements and the daughter elements? Before the crystallizing, daughter elements and parent elements is all mixed together and we cannot actually see the difference. But after the crystallization, you start with the 0 daughter element, but it accumulates and could not go somewhere else because it's stuck in the mineral. So that's the constraint, and we can see the difference. Yeah.
Gonna move on.
Yep.
Thank you. That was terrific. Really interesting. Thank you. So we're halfway through. How are we going for time, Mike?
Yeah, all right. Well,
not too bad.
Maybe we'll get everyone to stand up for a second because
Yeah,
it's
that's
halfway
yeah.
through,
Please
and it's a long slog.
get up and
just reset your brains and your bodies for a second.
have
and
a
just
stretch.
Give it a quick shake. Okay, that's enough. Sit down. All right.
Now we begin a series of two presentations in biomedical. Victor Barrichello, would you mind sitting down?
Sit down, please. You give people an
Yeah,
inch.
that's right, exactly. I'm like a headmaster here. I'm not going to, I know who you are. I'm going to don't make me name names. A couple of presentations are in Biomedical Health Sciences, and the first comes from Ong Zozo Biol. I think I tried to do that as well as possible. He's from Monash University. His lead supervisor is Associate Professor Joanne Ryan, and the presentation is Health-Related Quality of Life in Later Life. That's me. Predictors, trajectories, and health outcomes.
Good evening, everyone. Thank you, Royal Society of Victoria, for giving me opportunity to present my PhD finding. First, I would like to acknowledge traditional owner of the land on which we are meeting today. Let's start my PhD presentation with one question. What happened when you visit the doctor? Here, usually discuss the reason of your visit. Maybe you have your blood pressure check and your weight as a general index of your health. What about this question? How do you feel about your health? The work during my PhD has shown that individual perception of their own health provide really valuable information. Globally, as well as in Australia, cardiovascular disease and dementia are the greatest cause of long-term disability claim for older individuals. As the aging is the most profound risk factors for the cardiovascular disease and dementia, our chance of getting these diseases also increase when we get older. If we get these disease, it may impact negatively on our well-being and also place an extra burden on our family members. So I'm sure everyone in this room, including me, do not want to be affected by the cardiovascular disease and dementia. So can we predict who is more likely to develop cardiovascular disease and dementia? This could enable early intervention to help predict the disease. My PhD project investigates whether a simple questionnaire asking the individual how they perceive their own health could provide new insight into the individual risks of the dying and developing cardiovascular disease or dementia. To address this, I used the ASPRI cohort, who is relatively healthy older people living in the community. The majority, 87% of the cohort were from Australia. Followed this cohort for 7 years and also conducted annual assessment. I used the SF-12 health-related quality of life questionnaire. It consists of 12 simple questions asking the individual about their perception of their own health. SF-12 included 2 main components, physical and mental aspects. Here are the same example question. I calculated physical and mental component score of health-related quality of life using the algorithm. Higher score indicate better perception of their own health. That is what I found in my PhD. People with a higher physical health-related quality of life at the baseline hearts are the less likely to develop cognitive decline, cardiovascular disease, and less likely to die. Mental health-related quality of life was also predictive, but only associated with the cognitive decline and dementia. It means that people with a higher mental health-related quality of life are the less likely to develop cognitive decline and dementia. So, these findings provide the solid evidence that physical health-related quality of life at a single assessment, that is a baseline, predict a strong predictor for the incident cardiovascular disease and all-cause mortality. But physical health-related quality of life may be susceptible to change over time. So, longitudinal pattern of the physical health-related quality of life could provide additional prognostic information. So, I added new perspective to the field by examining whether the longitudinal pattern of physical health-related quality of life could predict subsequent risks of cardiovascular disease and all-cause mortality. This figure shows the longitudinal pattern of physical health-related quality of life among my study participants. We can see that most participants maintain their good physical health-related quality of life over time. Approximately 14% have the notable decline over the first 3 years after that slight graduation. About the 6% of the cohort have the low physical health-related quality of life over time. Over an average 2-year follow-up, after the longitudinal pattern identification, I found that the low group had the highest risk of fatal cardiovascular disease and all-cause mortality, whereas the declining group had greatest risk of developing incident cardiovascular disease. So this shows that declining physical health-related quality of life could be the early indicator for the developing incident cardiovascular disease. This study is the first study in this field, and they provide the evidence that provide the information, the importance of the physical health-related quality of life assessment in predicting heart outcome risks, especially for the older people. So the next important step of my PhD project is to examine who are the more likely to have low or declining physical health-related quality of life. As we know, when we get older, we might experience more life course transition events, such as reduced income after the retirement, partner illness, partner loss, friend and family member illness, conflict with children and grandchildren, the death of our pet, and loneliness. So as a next step, I examine whether these factors influence physical health-related quality of life growth. That is what I found in this study. People with a low socioeconomic status, less income, no pay work, no voluntary work, experiencing loneliness, partner illness, friend and family member illness, many problems are associated with a higher likelihood of being in the low or declining group. Now my figure looks very complex with the direct association and the mediating factors. We can see that most economics factors have the indirect effect on the physical health-related quality of life, either through the stressful life event and loneliness, partner death, many problems, conflict with children and grandchildren have the additional mediating factors between the economics factor and physical health-related quality of life. These relationships were either through the loneliness. This is also the sum of the first study for the Australian. It highlights that the role of the social welfare policy then enhance the economic autonomy and the social support in order to promote the well-being in older people. Bring it all together, loneliness, economics factor, some recent stressful life event have the impact on the health-related quality of life, particularly for the physical aspect. Lower health-related quality of life was associated with a higher risk of incident health outcomes. So my PhD finding highlight that inexpensive, self-reported, health-related quality of life has a direct clinical implication. It could be the part of the standard outpatient health risk assessment, especially for the older people in the primary care setting. So my finding reflects the paradigm shift toward the patient-centered care in this 21st century, and also support the government health policy initiated to incorporate health-related quality of life into the health system. All study of my PhD project has been published in the different academic journals. In addition, my novel finding has been highlighted in the editorial and the newsletters for the clinician as a new, much needed overlooked perspective in the multidimensional approach for the chronic disease prevention. In addition, my finding also received the media attention and the highlighting that personal insight may predict future health events for the older people. Thank you for attending my presentation. Thank you, Rise Society of Victoria and panel member organizing committee of the today events, my PhD project supervisor, Esri and Asop, participant and the key collaborator and the team member. A special thanks to the Monash University Graduate Research Scholarship for my PhD journey. Thank you.
So if I keep thinking I'm really healthy, I'm less likely to die.
Yeah.
Is that right? Okay.
Sure.
That's what I thought. Questions? I know Jane will have a question.
Yeah. That's a sweet presentation. Okay.
Thank you.
Because it's really meaningful. And you can show an 80% increase in mortality for the people in the lowest self-rating group. That's highly significant. And there's not a soul in this room that ever wants dementia. So congratulations to you on this. It would be brilliant to see this evolve into future work that looks at modifying the trajectory for people who initially self-assess with such low scores and what the impact on longer term in their mortality and the incident diseases that you're following become. Will you be looking at that in the future?
Yes, sir. If I got the findings, and I will. I'm also planning to look at these types of the research. If I got the finding for my postdoc.
Costas has got another question.
Thank you. Look, a very, very meaningful topic and wonderful data. My question relates to the contextual awareness of the group, because one of the outputs of your work is certainly on financial policy. I also noted the significance of loneliness, in your outputs, and I'm wondering whether different cultural belonging in terms of maybe again looking at non-English speaking cultures,
yes,
Asian cultures,
yes,
Mediterranean cultures.
Yes.
I'm just wondering, in a country especially like Australia,
yes,
whether there are opportunities to look at data which is culturally aware?
Yes. That is one of the future study from my PhD finding. So I thought we should conduct this type of the research using the multi-ethnic cohort, especially the Asian peoples and the other European people, and then some other mixed culture people, mixed culture cohort. So I thought that it is a future research for my from my PhD project. So that is beyond my PhD finding. Yeah. Thank you for your suggestion. If I got the funding for my postdoc, then I would definitely do.
What you're saying is that it's not the event itself, but it's the person's interpretation of the event which is causing the health change.
Yeah.
Right?
Yeah.
Okay.
It's like reactive observation.
Everyone feeling good?
Well, I am now. I feel great. I've decided. Right, here we go, Bill.
Very interesting as one who's entering that sort of one of the phases. Oh, yes, I know we're here. How much can you, I think, I may be wrong, but I think there are genetic tendencies towards dementia. How can you separate that effect, genetic effects, from your overall trends? I think some people are predisposed to getting dementia, whether you're highly active, social, have lots of family. For example, Peter Reith, the minister, he died after a battle with Alzheimer's. Now, he would have been active, have a high social, lots of contacts, he'd be a high achiever. How do you explain that?
Yes, it is a really good question. I will show the one slide for my question of the mental health. That is a question, example question for the mental aspect of the health-related quality of life questionnaire. So then you can see that it means that how much of the time you have the downheaded or the depressed. That is a 5 option to answer. This one is how much of the time have you accomplished less than that you would like to work, especially for the regular daily activity because of your emotional problem. So then this also has the 5 option. So then I mean that for my studies and the overall follow-up is around the 5 years. So then we answered this question at the baseline, at the very beginning of my study. So then my research is explaining is people answering the higher the mental health related quality of life at the baseline are the less likely to develop cognitive decline and dementia. So then that's why based on my PhD finding, we suggest that just a health-related quality of life could be as a part of the standard outpatient health risk assessment. It means a health risk assessment, and if you answer this question before the 5 year, for example, if you answer this question around the 2000, and then after the 5 years or the 6 year in 2006 or 2005, if you answer the lower mental health related quality of life at the 2000, your chance to get the dementia and cognitive decline is very high in the 2005 and 2006. So as another one is we need the future research based on my study, because as you know, dementia is a long, silent, asymptomatic phase. So then the 5 year is not enough. So then we need the further study with the more than 10-year follow-up is required to enhance my novel finding. That is the one reason I didn't conduct mental health related quality of life trajectory in my PhD project.
Okay.
Thank you.
Thank you, that was wonderful. Final 2 presentations are in the biological non-human group. And the first is from Linda Riquelme from University of Melbourne. And her lead supervisor is Professor Peter Vesk at the university. And she's measuring grass from space, which is good because Paul wants to water it. Yeah, it's good. Oh, sorry. I apologise, Daniel. I've missed.
What's going wrong?
You know,
This is just terrible.
just out of order.
Just
out of order, mate.
Linda and everything. Okay.
Let's do that again.
We're up to Daniel, yeah?
Yeah, can you rewind the tape? Yeah.
Okay, here we go.
Next is, sorry, Daniel. Daniel Urrutia Cabrera is University of Melbourne. His lead supervisor is Associate Professor Raymond Wong. And his topic is using cellular reprogramming and CRISPR technologies to regenerate the retina and treat vision loss. Good thing I'm getting old, but you're on the ball.
Hello. Thank you for the opportunity to presenting my research. And as you mentioned, I'm a PhD student from the University of Melbourne. I'm from the Centre for Eye Research Australia. And I'm also going to talk about the retina. So the aim of my PhD is using cellular reprogramming to regenerate the retina and to treat vision loss. So let's begin. I'm also going to ask you a question. I want you to think about how would you feel if you had to face your everyday life with your vision looking like this or in complete blindness. Seems impossible, right? Unfortunately, this is what people living with photoreceptor degeneration have to face every day. Photoreceptors are cells that are key for our vision. They are located at the back of the retina, and they are responsible for detecting the signals that are in the light and that our brain needs to form the images that we see as vision. So that's why when we have diseases that damage the photoreceptors, it has a profound impact in the quality of our vision, and it can often lead into blindness. We have two types of photoreceptors, rods that regulate the vision during night or in dark conditions, and cones that regulate vision during daylight and the detection of color. So I am particularly interested in cones because that is the type of vision that we use most of the time. In fact, that is the type of vision that we're using at the moment to look at all these amusing presentations, well, not amusing, but entertaining presentations. So as I said, when we have a disease that affects the photoreceptors, it can often, it results in visual impairment and it can develop into blindness. And blindness is it's a huge global problem because it creates profound impact in the quality of life of a patient, and it also has a huge burden on our societies because it creates problems like isolation, psychological problems, not to mention the financial burden that it places on our health system. The death of photoreceptors, it's a process that is irreversible. And in most cases, there are no treatments to restore vision once the photoreceptors are dead. The current approaches to treat these diseases is just to help the patients manage the disease or just prepare them to live a life with visual impairment or blindness, which is not ideal. Popular examples of diseases caused by photoreceptor death are age-related macular degeneration, or AMD, which affects almost 196 million of people in the world, and retinitis pigmentosa that affects 1.5 million worldwide. Luckily, there is a light at the end of the tunnel, and novel technologies like gene therapies are a promising avenue to treat vision loss. In fact, there's a prominent example called Luxturna, which is a gene therapy that uses viruses and that it has been approved in many parts of the world, including Australia. Luxturna treats a very specific type of retinitis pigmentosa. So unfortunately, it is only applicable to a very small percentage of patients living with visual impairment. So that's why in my PhD, I want to develop a treatment that would be applicable for all patients living with visual impairment caused by photoreceptor death. It is based in a technology called cellular reprogramming that was awarded the Nobel Prize in the 2012. And when I first heard about this technology, I was amazed because before we used to think that the identity of mature cells was a definitive state and it couldn't be changed. But now we know that we can take cells of a patient, like let's say skin cells, and reprogram them to become other tissues like neurons, heart muscle, and even photoreceptors. But how do you reprogram a cell? The answer is in our DNA. So basically, all the information that we have that we need to make all the tissues of our body, it's already in our DNA. And the difference is how the cells use this information. For instance, I am particularly interested in a cell type called myeloglea that is in the retina, and I want to reprogram it into photoreceptors because they have more like a supportive role in the retina. They can also regenerate, so it doesn't matter if we lose some of them by transforming them into photoreceptors. And they have also been shown to have stem cell activity in other organisms. So going back to myeloglea, DNA, they have unlocked in their DNA the genes that they require to make myeloglea. But for instance, the genes that they need that encode for the recipe to make photoreceptors are locked. But with a novel technology that we use in our laboratory called CRISPR activation, we are able to activate specific genes whenever we want. So with this, we can unlock the genes that encode the recipe for making photoreceptors, and then we can promote these cells to become cone photoreceptors. So with this approach, I want to develop a treatment that would stimulate myeloglea into becoming new cones in a degenerated retina with a single injection, with the aim of replenishing the lost photoreceptors and potentially treating vision loss. The main challenge of cellular reprogramming is knowing the genes that you need to make the cell that you want, in this case, photoreceptors. So I developed a tool in the laboratory that allows me to detect the reprogrammed myeloglea into cones because they turn red, as you can see here. I coupled this tool with a potent technology called CRISPR activation screen that basically allows me to search all the genes within the human DNA to predict possible candidates that could make photoreceptors. In my experiment, I detected 196 genes that could potentially make reprogrammed myeloglea into photoreceptors, and I selected a few of them because of their importance in cone photoreceptor development. Next, I tested different combinations of these genes to try to find some that would be effective in reprogramming myeloglea into photoreceptors. And overall, I tested more than 100 combinations, and I was indeed able to detect some combinations that could reprogram myeloglea into photoreceptors because they turn red, as I explained before with the tool that I developed. We were also very happy to see that our new cone photoreceptors were functional because they could respond to light, which is a key characteristic of the photoreceptors. Now that I knew which genes could potentially, or I could use to make cone photoreceptors, we proceeded to do some preclinical studies on a rat model that has photoreceptor degeneration and visual impairment. So what we did was to put these cone reprogramming genes into viruses, and we injected these viruses into the eye of the rats. And 4 weeks after, we analyzed the effect it had in their vision. So we were very happy to see that our treatment was able to induce or promote a functional improvement in these rats for parameters that measure cone photoreceptor activity or the activity of other cells within the retina. And well, this is very exciting because it means that we're getting closer to at someday developing a treatment that could improve visual function after you lose the photoreceptors. I would like to finish summarizing my talk because I know that there were a lot there was a lot of information. So the aim of my PhD was to develop a cellular reprogramming protocol that could allow you to generate new human cone photoreceptors. And I also show you how the viral delivery of these cone reprogramming genes improve the visual function in a rodent model that has photoreceptor degeneration. So Overall, our results provide an important preclinical evidence for using cell reprogramming as a gene therapy to treat photoreceptor loss. I would like to thank the members of my laboratory, the cellular reprogramming unit, and of course, all our collaborators, because without them, this wouldn't be possible. Thank you.
Wow. Wow, Daniel, that was terrific. Let's take some questions. Councillors, judges. I thought David Walker might have a question. Rob Day first.
Yes, I'm very impressed, particularly as I worked with someone who had this sort of vision loss, and I appreciate just how difficult it is to set up these sorts of models, and there's a lot of issues about how it needs to be done. What I'm interested in is how you can tell whether you have developed cones or rods, because I don't think you covered that issue. The response to light would be with a rod or a cone. And how did you test that you had cones?
That's a great question. Yeah, those are experiments that I didn't put in the presentation because it's only 10 minutes and it's a bunch of maybe boring data for some of the people. But so we can answer these by in many different stages of the experimentation. So I want to go back. So first of all, this tool, it's a gene that has a regulator that it's only expressed or activated in cone cells and not in rods. So if the cells turn red, it means that the microglia entered a program, a stage where they resemble more cones. But of course, after that, we do some quality assessment where we look for expression of markers that are present in cone photoreceptors. We do all sorts of analysis, transcriptomics, and then going into the visual function. You're right, like you would see the image that I showed doesn't distinguish between rods or cones, which if we are making also rods, it wouldn't be that bad, right? Like we want the two types of photoreceptors, like the more the better. But there's also different analysis that we use in the laboratory to isolate just the response of cones. I didn't show it here, but it's basically a double flash. So what happens is that the first flash, your two types of photoreceptor would be activated. But if you shed another flash, really in a short time, the rod photoreceptors, they don't have the capacity to recover that fast. And then the cones do. So you only get the signal from the cones.
Walker.
Great talk. How did you produce the model of AMD? And I think it was rats, wasn't it? How did you do that?
Yep. This is a model that we just purchased because someone did the big task of developing the model. This one, I believe it was they introduced in the rat a mutation that is known to be present in patients. It's called P23H, and it's not really AMD. It's more retinitis pigmentosa, but it doesn't follow the same symptoms of AMD, but the end is the same, like photoreceptors die. And yeah, what happens is that the photoreceptors are not functional and they start to die when they detect the light because they can't just clean. They can't clean the. They can't recover, so they progressively die.
Okay, I would just like to suggest that if you want a transitional model, there are some breeds of dogs that lose their eyesight quite quickly from middle age and so on. That might be a good test bed for you for showing you can improve vision.
Thank you.
Thank you for your presentation. that the figures that you gave in terms of people affected by AMD and retinitis pigmentosa suggest that 1 in 40 people in the world have a visual deficit just from those causes, without adding in cataracts and other complications that humans suffer. So this has very profound significance. First of all, are there any barriers to applying this technology to rods, developing rods? Because whilst cones are important for all our vision in lighted settings, artificial and natural, you do need your rods for night vision. So important particularly for people who have limited access to artificial light. So that's the first question.
That's a great point. I'm not the only one working with retina regeneration with this type of technology, because it's really promising. So there's people working with rods. Many groups have done rods because I don't want to say it's easier, but you only have one type, and of cones you actually have 3 types. So it's a bit harder to tell which type you want to make. And also rods are a lot in the retina. So I guess it was easier before to just assess the effect of these therapies on rods. So it has actually been done in just mouse models. Like, we have never transitioned into humans. We haven't done that yet. And then there's other groups doing it with the cells from the optic nerve to treat diseases like glaucoma, for instance.
That's it. Daniel, you'll have to ask the second question later. Thank you, Daniel. Now we move to the biological non-human presentations, and the first is Linda Aquelmi from University of Melbourne. Her lead supervisor is Professor Peter Vesk, and she's measuring graphs from, or have been measuring graphs from space. Terrific.
My turn now.
Our fault. Go ahead. I'll scrap that out of your way. Clear the decks.
Okay. Hello, everyone. Thank you for including me in this wonderful event. I want to start by acknowledging the Wurundjeri Woiwurrung people of the Kulin Nation as the traditional owners of the land on which we meet today, as well as the Wotjobaluk people on whose lands I did all my fieldwork up in the Mallee. I pay my respects to their elders, past, present, and emerging. So before I talk to you about measuring grass, I want to talk to you about why we care. Why is that important? And that's because of these woodlands up here, up in the Mallee. These are bull oak woodlands, and they're the focus of my management talk. So these are an endangered ecological community. They're found throughout the Murray-Darling Basin, but they've been greatly reduced. Why? Because of extensive historical clearing for grazing, for agriculture, and even though a lot of these stands are now found in national parks, they're still grazing by rabbits and by kangaroos and by goats. And these inhibit the regeneration of any seedlings. So in some areas there hasn't been any regeneration for several decades, which is really worrying. So there was some work done several decades ago that looked at the diet of kangaroos and the proportion of grass in relation to how much grass was out, available to them. So they found that below a certain amount, which was about 400 kilos per hectare, which is not very much, they start to forage on other things, so shrubs or tree seedlings. And it's at this point that there is that, that risk of browsing, which has happened here to this poor little bull oak seedling. That's never going to be a proper tree. So why is this important? Well, managers want to know, how much grass, how much food there is available to kangaroos, because although they carry out kangaroo culls to reduce that grazing pressure, because there is no longer any, the top predator has been removed, dingoes, there's not hunting anymore. So, to avoid an, overpopulation of dingoes, where they might, when times are tough and there's not enough grass, they'll starve or, inhibit the regeneration of vegetation. yeah, they want to be able to refine and be more confident about whether they really need to cull and when. Yes. So I sought to understand how much biomass varies in the landscape. So how does, where does grass grow? How much does it grow? What influences it? So the two questions I asked, the first was, in which areas of this park are bull oak seedlings most at risk from browsing? And the second was, how do we best measure this risk at such a large scale? So to address the first one, I and some wonderful volunteers, we all went out and sampled biomass. So that was a lot of clipping and putting grass in bags and then drying and weighing. We sampled biomass over a period of 2.5 years, went out in different seasons, in really wet and really dry periods. And we sampled over a whole lot of vegetation types. So Pine Plains, where I did my field work, it's really patchy. There's dry lake beds, there's some black box woodlands and bull oak woodlands. Yes. So what we found was that, so here we see the orange lines. These are open sites, so like the lake beds and the cleared grasslands, the cleared bull oak woodlands that didn't become grasslands. And these are the wooded vegetation types. So we see that actually the wooded vegetation types are really forage stress. There's not much grass growing, especially in summer and autumn, which are these December, April. You see the orange line that represents that purported switch threshold, at which point kangaroos will start eating shrubs and tree seedlings. So in the drier months, the grass biomass is really likely to fall below that. And so that's really important because, that's when these seedlings are probably going to be eaten. And woodlands are also really important because western grey kangaroos, even though they will go out to open areas to forage because there's a lot of grass, they'll stay close to trees because it'll provide them cover during the day especially, and they can go and run into safety. Oops, here we go. So even though field sampling, it's fine for exploratory work, over time, if you want to monitor grass availability regularly over a large space, it's really inefficient, it's really time consuming, very expensive, it's destructive. So what about measuring from space? How do we do that? Well, you can use remote sensing, so satellites to do this. Satellites such as Landsat measure reflectance from the Earth. So they scan and they capture that reflectance. And so they measure in specific bands. So this is, for example, these are the wavelengths, and here this is the red band width, and this is the near infrared. So these two bands are really important for vegetation because red light is absorbed by green vegetation, whereas if it's brown, it'll reflect it. So when you have that difference, that'll tell you, whether there's green vegetation or not. So a higher value here, for example, indicates that. So I explored different vegetation indices, so combinations of those bands, to see whether they could give a good indication of grass biomass. It wasn't always very clear. Sometimes, for example, these are two indices here associated with grass. One shows that actually with this index, there's less grass biomass. With this index, it's associated with more grass biomass. It's a complex thing, the relationship between biomass and the reflectance, because of a few reasons. One of them being tree cover. Landsat pixel sizes are 30 metre by 30 metre. So for each pixel, there'll be a single reflectance value, and that's an average of everything within that pixel. So if you have a lot of tree cover with green leaves, and like in this picture, that suggests there's high biomass, but actually, if you want to look at grass biomass, it's not very clear what you get from that picture because there's not much happening underneath. It's not very green. It can also, obscure the ground layer vegetation as well. Changes in soil moisture, the timing of rainfall events, the amount that will influence the biomass. And up in the semi-arid, you have really localized rain events sometimes. the amount of dry vegetation on the ground. So when you have a lot of dead vegetation, it actually gives a signal that's similar to bare ground. That's, yeah. So while there is more biomass in this picture than in that one, they have a similar value, which has different implications for food, for forage, if the kangaroos will eat the brown stuff as opposed to dirt. All right, so going back to those two questions that I had. One was, what are the areas where the seedlings are most at risk of being browsed? Well, woodlands. That's a short answer. So we saw that grass biomass will pretty much always fall below that threshold in summer and late summer and autumn. And kangaroos, they prefer these areas because of that, you know, that availability of grass in the open areas, but they're close to shelter. So that's, yeah, key area there. How can we best measure this at a large scale? But maybe not remote sensing unless you include other data to improve accuracy. Like, for example, we found that tree cover was really important, soil moisture as well. So unless you have all of those other variables, remote sensing by itself, it's a little complex. But I'm working on other methods, testing other methods that I use out in the field. For example, rising plate meter, which is a rod with a little cardboard plate. You drop it, measure the height. That's quite a quick and effective tool. Or a handheld scanner, which does the same thing as a satellite, but at a much finer spatial scale. So much more accurate, but more expensive. And there's also pasture models available online. They're much more coarse, but you know, testing whether they're actually enough for this purpose. So watch this space. If you want to read more about what I've been doing, have a look at my 2 papers. Well, they're a bit small there, but open source, you can read more about them, or just ask me. Yeah, I'd like to thank all my supervisors and my wonderful volunteers, and thank you all for listening.
Thanks, Linda. Linda, you've prompted me to ask, completely unrelated, is Outlet Creek flowing with all this rain?
Oh, I'm not sure. It's never flowed in.
It hasn't flowed since about 1972 or 3.
Yeah, no.
I'm just interested because I was going to ask you a question about the Interdecadal Pacific Oscillation, whether we're in the wet phase and blah, blah, blah. But I'm going to ask a question. Is there, there's a bit of thought that we've moved into a IPO in 2010. We don't know enough. Have you thought about using any other measures for biomass? Is there paleoecological data, for example, that might give you some idea about what biomass might have been in, 1750 before we all turned up and before rabbits turned up and we started, before we invented the bulldozer?
No, I haven't looked at that, but that will be interesting. We know that more tree cover inhibits biomass on the ground, like grass and herbs and shrubs. So we can infer from that, prior to all the really systematic land clearing, that there was less grass on the ground. And, records suggest that there were fewer kangaroos too. Also, there were more dingoes and there was more hunting. So it was a combination of things.
It's a big change.
Yep, very big.
Okay, Rob?
No, sure. Yeah, really interesting stuff. But if I was a bullocky tree, the most useful place to actually start recruiting offspring would be some distance away from the woodland in the grass.
Yeah.
And if this has been the pattern in the past, that there's much less grass in amongst the woodland and therefore the grazing would be higher there, you'd expect that to have happened.
Mm-hmm.
So is it true that the trees only recruit close to the seedlings only recruit close to the trees, or do you find seedlings away in the grassland that are successfully recruiting?
Great question. So the first part of the question, where with recruiting out in the open, so Natural recruitment is more difficult because it is further away. The seeds have to get there. There has been work done by Amy Bennett and others that did some plantings out in open areas and in wooded areas, and they compared, different grazing regimes, so excluding, and actually when they planted out further away in the open areas, if there was a barrier to grazing, all sorts of, like kangaroo and rabbit, they actually did pretty well. So, I mean, it's an ongoing monitoring still, but yes, so this is another strategy is replanting. So definitely out in those wooded areas would definitely be important. The second part was the distance from the parent tree. So there was work done by John Morgan a few years ago where he and others tested how far away from a parent tree seedlings could survive, and it was anything closer than about 13 meters, the parent tree will inhibit because of soil moisture uptake or nutrient depletion. So there has to be, it's sort of like a sweet spot for natural regeneration to occur. Yeah.
Thanks. Just a question and a comment, really. Catastrophic events such as wildfire and cyclones very often reset these woodlands and savanna ecosystems or semi-arid woodlands. Is it possible that the natural regeneration is very episodic, very infrequent? And if so, have you looked at aging the bull oaks to see whether there are cohorts that sort of regenerate when you have these extremely wet periods, so that the grass is able to, in a way, nurse the trees from seedling to sapling?
Yes, thank you. I haven't, but I know other people have. I think Fiona Murdoch, 2005, did a PhD on this up in a couple of Mallee parks, not Weiperfeld, but looking at this, and other people have done work in other areas. So some people have found evidence of this episodic recruitment with increased rainfall, which is really important. And I think Fiona Murdoch found that recruitment can happen even without the heavy rainfall, but so it's a little mixed. I haven't done any of that work myself, though. Yes.
I think we're. Hang on, Bill. Yep.
Yeah.
It's probably more of a comment than a question, but there are two historical factors which greatly influenced the vegetation in the Mallee and Wimmera, and that was traditional owner burning and the effect of the millions of small native marsupials that grazed in different ways that are now gone.
Yeah.
So I don't know how that factors into your work, but it's an important historical to recognise what effects those two issues have had.
Yeah, for sure. I mean, as far as I know, there is no, well, up in Weiperfeld at least, no cultural burning. As for the marsupials, yeah, really the only marsupials that remain that have been seen are the western grey and the red kangaroos. All the smaller ones have gone.
Cats and foxes are fixed in.
Cats and foxes, yep.
Thank you, Linda.
Thank you very much.
Thank you very much. Our final presentation is Michelle Xu. Where's Michelle? Yep, from RMIT University. Her lead supervisor is Associate Professor Peter Torley, and her presentation is Protective Cultures as Natural Antimicrobials for Fresh Meat Shelf Life Extension, the Application and Consumer Acceptance. Welcome, Michelle.
Good evening, everyone. Thank you for being here. Nowadays, because of the busy lifestyles, a lot of us don't have time to go grocery shopping every day. So what we do is to buy a lot of food each time when we go shopping and store them at home and eat over a period of time. But often, some food spoil before they get eaten. Have you ever thrown away unused food at home? I have, and I'm sure the answer is also yes for a lot of you. But this doesn't just happen at our homes. Food waste is generated at every stage of the supply chain, Globally, 1/3 of the food produced for human consumption goes to waste. And in Australia alone, we waste 7.6 million tons of food each year. And this costs our economy more than $36.6 billion. Apart from the economic losses, food waste also has significant environmental impacts because the resources used to produce the food, such as land and water, also get wasted. And not to mention a lot of the food waste goes to a landfill. One way to reduce food waste is to increase food shelf life, so we can get more time to finish the food before they spoil. For different food products, there are many different ways to extend shelf life. And so during my PhD, I work on the shelf life extension of fresh meat products. A major factor limiting the shelf life of fresh meat products is the action of spoilage bacteria. So controlling the growth of spoilage bacteria would be an effective way to make fresh meat last longer. And because today the consumers demand for more natural food products, for my PhD, my research looked at a new natural method for fresh meat shelf life extension. That's by using protective cultures. Protective cultures are microorganisms with the ability to control unwanted microorganisms in food. They are natural and safe to consume. The concept is similar to adding starter cultures to milk to make yogurt. But instead of using the starter cultures to make fermented food products, we use protective cultures for their antimicrobial functions. So for my PhD, I was wondering if protective cultures could be applied to fresh meat products to inhibit spoilage bacteria and make the meat products last longer. Because using protective cultures to extend meat shelf life is a non-conventional method, my research evaluated the practicality of this approach from both the technical application and the market acceptability perspectives. And next, I will show you the main findings from my research. For the technical application of protective cultures, first, I tested 6 different protective cultures on lamb back straps stored in 2 types of common retail packaging. And this was done by, so I did this to first confirm if the protective cultures could actually work against the spoilage bacteria. And I did this by comparing the growth of spoilage bacteria at the end of storage and to see the difference between the lamb back straps treated with protective cultures and the normal meat untreated with the protective cultures. And the 6 protective cultures I tested contain different combinations of the 4 different bacterial species shown in the table. And the 2 packaging systems I tested were modified atmosphere packaging with 80% oxygen and 20% carbon dioxide and vacuum packaging. Results showed that protective cultures were overall more effective in vacuum packaging, and they caused up to 4-log reduction of spoilage bacteria compared to untreated lamb back straps. And in modified atmosphere packaging, they only caused up to 1.8-log reduction of the spoilage bacteria. So from the results of the initial testing, I selected culture 1 and culture 4 as the 2 of the most effective protective cultures in vacuum packaging. And then I studied them in more detail to understand their effect on spoilage bacteria during storage, their potential to be used in a variety of meat products, and their impact on meat quality. I applied the 2 protective cultures to 2 different types of fresh meat products. One was lamb back straps, again, to represent intact meat cuts like a steak. And the other one was beef mince, including lean mince and standard mince with higher fat content. And the findings were very interesting. Enterobacteriaceae is a group of common meat spoilage bacteria. So I'll use this one as an example to show you the effects of the protective cultures on spoilage bacteria. On lamb back straps, the levels of Enterobacteriaceae on untreated samples increased rapidly in the second half of storage. And on backstraps treated with the protective cultures, the increases were much less. In beef means the growth trend of Enterobacteriaceae in lean means was very similar to that of lamb backstraps. As you can see, the protective cultures suppress the growth of these bacteria. But in the standard means, with higher fat content, the protective cultures did not have any effect on the spoilage bacteria. This means that the same protective cultures could be used in both lamb and beef and in intact meat cuts and minced products to effectively control the growth of spoilage bacteria. But their application may be limited to lean or low-fat meat products. In terms of meat quality, the two protective cultures in general had minimal impact on meat color and texture, but they slightly decreased meat pH, and it would require further research to determine the practical significance of the pH decreases. After testing the protective cultures in meat products, we see this approach has great potential for fresh meat shelf life extension. But if consumers don't accept this approach, it's not going to be very meaningful. So I conducted a national online survey asking 803 Australian consumers whether they would be willing to buy and eat fresh meat products with added protective cultures, if these products could last longer and for the same price. So the results show that overall, 15% of the respondents said they would be more likely to buy, and about half of the respondents said it would make no difference. And if we add these two categories together, it means at least 63% of consumers would be willing to buy meat with added protective cultures. And only 18% of respondents said they would be less likely to buy. For consumers' willingness to eat meat with added protective cultures after being cooked, results show that overall, 46% of respondents said they would definitely or probably eat, and only 11% said they would not eat. So with only small proportions of respondents not willing to buy or eat meat with added protective cultures, consumer acceptance of these meat products would unlikely be an issue. These are the major findings from my research. To summarize, protective cultures can effectively inhibit spoilage bacteria in fresh meat products with low impact on meat quality, and they are likely to be accepted by consumers. Therefore, protective cultures have great potential to be used as a natural solution for fresh meat shelf life extension to help us reduce food waste, save money, and save the environment. Thank you.
Thank you, Michelle. Now, I'm guessing you're aligned a little bit with the Food Waste CRC at RMIT, are you?
No.
No, you're not. Oh, there. All right. Now, how did you choose your 803, or was it 830? Your sample
No,
size?
we had, because for the survey study, there's a minimum number of sample size we have to meet. And so we try to get, like with the budget, we try to get as many people as possible passing that minimal number of requirements. Yeah.
Questions, judges? Daniel has one as well. Daniel stepped out of the circle as a presenter. He's going to.
That was absolutely fascinating, and what an impact it would have on the food industry. Actually, I was speaking to Woolworths just this week about tackling food waste, and it is absolutely really high on their agenda. Are either the main supermarkets or the meat industry aware of this research?
Actually, my project is sponsored by Australian Meat Processor Corporation. So, like at the start of my project, we were trying to do something that can be very useful for the industry, like that can be applied to health. Like because I was interested in the food waste issue, I picked this topic. Yeah.
It's absolutely fascinating, but I want to know, does it change the taste of meat? Have you done kind of like a double-blind trial of?
Yeah, that's a very good question. Actually, when I started my project in 2018, the plan was to do some laboratory testing with the cultures plus a consumer sensory testing. And then I got everything done, and including the ethics approval. and then COVID happened. That's why I changed to the online survey instead. Yeah, that's a pity, and that was something I really wanted to do to find out. Yeah. Thank you.
Thank you. Lovely presentation. Most interesting. How did you select the 800 plus people that you surveyed? Not the number. You said how you chose that number. What I want to know is how you recruited those people. Did they self-select? How did you approach them and set that up?
So at first I was thinking just to do like on social media or through the university. And then after talking to some people doing similar research like in our university, I found like that's not going to be a good method. A lot of people struggle to get a good panel. So I turned to a market research company. I actually use Qualtrics. So I just use like, they help me research the panel and collect the data, and I just analyze the data.
My question was who was on that, because you talked about at the start people not having the time to shop every day. So I would suggest if I live in Brunswick, I can probably go to the Coles almost every day to buy fresh produce and meat. If I live in Pakenham and I'm going to the Woolworths, I probably go once a week because I don't have the time. So is it worth exploring doing further study and actually picking out people in particular sort of socio-economic and geographical areas?
Yeah, for the survey, I just presented the overall percentage, but actually we asked a lot of demographic questions in the questionnaire, including the location, the age, gender, where they live, like their shopping habits, meat consumption, meat shopping habits, like a lot of questions, and we analyzed. Actually, for the location factor you mentioned, there is like we couldn't go down to each suburb, but because it's a national study, we just analyzed by the states and also by metropolitan and regional areas. So between states, there were no difference. And between the metro and regional areas for, I think I forgot is for the willingness to buy or eat, there was some significant, but not a lot of difference in that, in location. Yeah.
Michelle, firstly, I'm surprised you got a photo of my fridge right in the beginning. I didn't know there was a camera in my refrigerator.
That's from Adobe stock.
I'm curious, is there any change in the nutritional value of the produce? And did you even land up exploring that? I know you increase the shelf life. And the other thing was, I'm thinking, can you draw any parallels from this to, say, vegetables? You know, are you able to sort of extrapolate that in terms of your findings?
So the first question was there any nutritional changes?
Yeah.
That's beyond the scope of my study, so I'm not sure. But I don't expect there to be nutritional changes. And the second question was, it could, but I think it can work, but it has to be different cultures, because the cultures I used were for meat products, and you can choose the ones to target the vegetable bacteria.
Yes, I was particularly interested in this, but I'm wondering about the longer term effects of these cultures. I mean, presumably the bacteria that you have on the culture at the start changes over time. And so how long would the protective effect last if you leave it for a longer period than your study?
It depends on a lot of factors. So an important factor is the initial contaminating bacterial load. If you have a lot of starting unwanted bacteria in the product, the protective cultures may not even work. And as I have shown in my talk, factors like fat can affect their performance. And as you know, meat products often vary a lot in fat content. So to answer your question, it has to be, you have to do the testing for a particular product and for long enough period to know the answer. We can't just guess that. Yeah.
Okay, thank you, Michelle. That's terrific. Thank you very much indeed. It's now time for the judges to consider their verdict and a minor change of plans. You're all going to stay here. You can't have a drink just yet. But I promise you the judges will be very quick. They'll be very efficient in their assessment. But we do have a good, lovely video from Professor Brendan Wintle, do we not? We do. To entertain you for a few minutes whilst our judges retire to the Cardmore Library to consider their verdict.
Okay, let's see what sort of Frankenstein's monster of a presentation I can just get up here for you all. This is in particular for the people who are watching via YouTube at the moment. We don't want to just dead space for the next 10 minutes. For those in the theatre, if you'd like to sit and watch Brendan do his thing, that's great. If you want to stand up and walk around a bit and go to the toilet and all those sort of things, that's fine. You're not expected to be bolted to your seat. But I will nonetheless endeavour to get something up which is hopefully mildly entertaining for the folks at home. Yeah, where is that? What's going up through here? Here we are. Okay, what fresh hell is this? There. You got that? I'll just do a little test of the system. This is connecting. Anything? Ross, have you got a signal coming from the computer? No, I mean as a audio signal. I'm not getting the audio. So it's on the last two. It's those two line in. Yep. What sound? Has this got sound up? Yeah, it has. That's it. Oh. Oh, it's going out through HDMI. That's why. Click that little arrow. Yep. Go to the speaker. Okay. There we go. Aha! We have sound. This is excellent. Yep, all good. Okay, here we go. All right.
Well, thanks very much for having me here to the Royal Society of Victoria today. It's great to have the opportunity to talk about this topic that I think is really crucial to our own persistence as a species, and obviously it's very important to me in my work, and I hope you'll find it interesting. I'm going to start straight into some politics. Back in 2010, Minister Burke, on behalf of us and with 192 other signatories, declared that by 2020, the extinction of known threatened species will have been prevented. Their conservation status, particularly those most in decline, will have been improved or sustained. So this is a big promise to the rest of the world and to future generations to arrest what has become known as the extinction crisis, to start to turn around ecosystem decline. And that promise has actually been transcribed almost verbatim into Sustainable Development Goals. I'm sure many of you will know of the United Nations Sustainable Development Goals. They set out a pathway for trying to achieve a sustainable future for the planet, and they're very important commitments that governments have made around the globe that we can use to actually hold our governments accountable to the promises that we've made. And particularly the Sustainable Development Goal that I'm interested in today is the endeavour to take urgent and significant action to reduce the degradation of natural habitats, halt the loss of biodiversity, and by 2020, protect and prevent the extinction of threatened species. So how are we doing? Well, as usual, with many of these types of promises, there wasn't a whole lot of thought given at the time about how we were going to measure our performance towards those 2020 goals. And indeed, now that we are past 2020, how we will reflect on our progress towards these HE targets and the Sustainable Development Goals. So back in 2016, the governments that signed on to the Convention for Biological Diversity developed a program called the Intergovernmental Platform for Biodiversity and Ecosystem Services. One of the main purposes of this body was to actually be able to track how we're performing against these international or global commitments to conserve biodiversity and ecosystem services. And a key output that came out in 2019 was the IPBES Global Assessment. And that's really tracking how we're progressing in terms of ecosystems and biodiversity as a planet. This is an amazing collaboration of over 350 scientists, policymakers and practitioners from around the globe that draws on environmental evidence and data from literally thousands and thousands of studies and programs to study nature and ecosystem services. It's a huge effort to actually, and an unprecedented documenting of the globe's state and trends in terms of biodiversity and ecosystem services. So what has the IPBES Global Assessment found? I'll take a step back first of all and just talk briefly about what ecosystem services are. I'm sure most of you have heard the term ecosystem services, and probably some of you are very familiar and perhaps even work in the domain of ecosystem services. Bob Costanza, back in 1997, very conveniently defined ecosystem services for us as the benefits provided to humans through the transformation of resources or environmental assets, including land, water, vegetation and atmosphere. And this brings goods and services to us. And we can break down those services into provisioning services. These are the basic things that we rely on for life, like food and raw materials and medicines. Regulating services, this is the way nature actually allows life to exist by regulating air quality, climate and temperature, rainfall, cleaning air, cleaning water. You can imagine the sorts of things. Supporting services, so the basis of life, photosynthesis, soil formation processes and nutrient cycling. And then these cultural services, spiritual and religious values, the way we relate to nature as humans. We've sort of grouped into these cultural, aesthetic, spiritual, recreational and mental health services. And these are critical for our life. And so these ecosystem services are the benefits that nature brings to us as humans. One of the key questions in conservation science is how much should we weight this ecosystem service angle, this kind of, we need species to survive ourselves angle versus, the existence value of a species, what it means to actually have a species go extinct after, 50, 100 million years of evolution. It will never be observed again by any other human. I think, there's issues around the intergenerational equity. There's issues around, as you say, culture and heritage. And then there's the sort of existential issues around, well, if we keep losing biodiversity, if we keep losing genetic diversity, then we are losing opportunities to solve problems, and we're losing quality of life. And look, no, there's no answer. There's no clear answer. I don't think we focus too much on the cultural myself, because that's my viewpoint. I believe largely that it is about not so much the right to exist, but the right for everybody to experience nature and biological diversity in its most magnificent form. And if we take away future generations' opportunities to do that, then I think that's a dreadful breach of contract with future generations, and it's extremely tragic. So for me, that's the key issue. And it's also about our own quality of life, because my God, if you can't go out into the bush and just see how incredible it is, and see a possum or see a plant, because it's gone extinct, I just think that's an immense tragedy as well. So, yeah, look, there's lots of elements to that. There's also having respect for the culture that was here before Europeans came, and their culturally significant species, and making sure that, to the extent possible, we can avoid continuing to plunder and ruin that amazing environment that they were the stewards of for, probably 80, 100,000 years. Goodness knows. The numbers change every couple of years, don't they? But that's a big part of it as well. So the global assessment of biodiversity and ecosystem services found something that I'm sure you're all quite aware of. Nature underpins all aspects of life. 2 billion people rely on wood as their primary energy source. 4 billion people rely primarily on natural medicines. And 70% of all drugs are natural or copies of natural drugs. 75% of all crops are animal pollinated. This is a really crucial story I'll come back to in a minute. And natural systems are the only carbon sink that are going to be viable for actually reducing the amount of carbon in the atmosphere. And at 5.6 gigatons per year, there's no way we're going to be able to provide an artificial carbon sink that's going to come anything close to nature's ability to actually sequester carbon from the atmosphere and store it in biomass. Natural pollinators, it's estimated, are worth around $560 billion a year to the global economy. So the loss of natural pollinators is potentially an immensely troubling existential crisis that we face as humans. But of course, the capacity of nature to deliver these benefits to us is declining everywhere. So let's have a look at one of the headline figures from the IPBES global assessment. So first of all, the rows in this figure indicate these key contributions of nature to people. And so you can see up the top here, habitat creation and maintenance, pollination and dispersal of seeds and other propagules, the regulation of air quality and so on. These are nature's benefits to people. This next column here indicates what the 50-year global trend is for these services. And so you can see here that habitat and creation and maintenance has a downward trajectory. It's very strongly decreasing. And this donut here in the next column indicates that this is a global result. So this is happening everywhere. And over on the right-hand side, you can see some examples of some of the indicators that are used to measure the state and trend of nature's ability to bring these services to us. And so there's a couple of interesting ones here that I'm sure many of you will have thought about a lot recently. The regulation of hazards and extreme events, the ability of ecosystems to absorb and buffer hazards is declining and continues to decline globally. This is a strong trend, and you might remember quite acutely for some the 2019-20 fires, an example of a natural hazard that has been exacerbated because the ecosystems can't absorb the hazard in the way that they used to, so that we've seen the loss of land for agriculture, the loss of habitats for species, the loss of human life, the loss of infrastructure. And it's partly brought about because nature has no longer the ability to regulate these natural disasters.
All right, we're going to have to stop Brendan there. Sorry, everyone. If you want to hear more about this particular presentation, just go to our YouTube site, Royal Society of Victoria. It is an excellent presentation, and you'll find many more there as well, which I hope you'll also enjoy. So let's bring the vision back to the room if we can.
And the judges did have, in two categories in particular, a very difficult task. And the president of the society had to use a casting vote on 2 occasions. But everyone's a winner. The winners of each category receive $1,000 and a certificate, and the runner-up receives $500 and a certificate as well. Mike, are we doing that? Don't know. From the top, in the physical sciences, our winner in the physical sciences category for our 2022 Young Scientists Research Prizes is Masjid Sagdapur. Now, yes, how do we do it? Where should we, how are we going to, let's do it in front of our wonderful front of here. Let's do promotion. Congratulations. Well done. Look at the camera. Very good. Well done.
Thank you very much. Thank you.
So, so that means Yongjing Wang is our runner-up, and very good presentation as well, as they all were. In the Earth Sciences section, winner is, and this was difficult, there's a lot of discussion about both presentations. Paul Chung is our winner. Well done, Paul. Move the camera and very good. Well done. So which means that Hosiang Lim is our runner-up, and a prize there as well. Moving to the Biomedical and Health Sciences section, a winner is Daniel Urrutia Crabera. Well done. Another category that we really all couldn't split these. So well done, Daniel. Good? Okay. And in the final category, the biological non-human category, our winner is Michelle Chu. You're going the long way around.
You're savouring your journey.
There we are. Congratulations. Let's look at the camera. Very good. Well done. And I mean, all of the presentations have been terrific, so I'm sure everybody's thoroughly enjoyed them. Mike, is that all we need to do?
Yes, there's going to be some photographs. We want all of our finalists together for some photos with our judges. That'll happen up here. Everyone else is willing to stick around and watch that if you like. What we want you all to do, so go downstairs and have some champagne and some food, which will be waiting for you downstairs, and help us celebrate with our finalists when they come downstairs to join you. So if you wouldn't mind sticking around just for another, say, 15 to 30 minutes or so, just to talk, and certainly when we join you downstairs, if you could join us in, informally congratulating all of our finalists. Our first prize winners receiving a $1,000 prize. Our second prize winners receiving a $500 prize. So everyone's a winner, Rob?
Everyone's a winner.
Everyone's a winner. So, so if we could have all the finalists and the judges up here, everyone else pop downstairs and bend the elbow for a little. And YouTube, we will bid you farewell. Thank you for joining us tonight.